Here's an example where we have to do structural decomposition on two different values. A traffic light changes color every 20 seconds. Given a traffic light color and the number of seconds until the next change, we need to write functions that return the color at the next second and the time until change at the next second. Let's start with our data definitions. A traffic light color is one of red, yellow, or green. The interpretation is self-evident. I've written down some examples which will be helpful when we go to test. Next we have our template, which we've seen before. Nothing new here. Our next data definition is for the countdown timer. A timer state will be a non-negative integer such that 0 is strictly less than t, is less than or equal to a constant which we will call color change interval. Interpretation of this value is the number of seconds until the next color change. If t equals 1, that means the color should change at the next second. Here's our constant for the color change interval. Now we can start writing our functions. Let's start with timer at next second. It takes a timer state and returns the timer state at the next second. So for example, timer at next second of 17 should be 16. Timer at next second at 1, well, it can't be 0 because that is forbidden by our data definition. And our interpretation says that when the timer is 1, the color should change at the next second. That means at the next second, we should have an entire color change interval until the following change. Our strategy will be cases. We will take the scalar datum, timer state, and decompose it into different cases that are treated separately. So if t is equal to 1, the answer will be color change interval. Otherwise, the answer will be t minus 1. And here we have our tests. We're ready to run these tests now, so we don't need to wrap them in a begin for test. Let's now move on to color at next second. Given a TL color C and a timer state T, we want to return the color of the traffic light at the next second. So, if, for example, our traffic light is red, but there are 7 seconds until the next change, then after a second, the traffic light should still be red. If our traffic light is red and there is 1 second until the next change, then at the next second, the traffic light should change to green. And here I have 2 more examples illustrating that after green comes yellow and after yellow comes red. And now I have turned these 4 examples into tests. So it's clear that in order to solve this problem, we need to examine both the traffic light color and the timer state t. Which shall we do first? Let's try each of them and see how each of them works out. So in our first version, we'll do structural decomposition on the color C. To do that, we will go pick up the template for color, copy it, uncomment it by saying uncomment. Let's make sure we have matching parentheses. Okay, now, if the color is red, what do we want as our answer? Well, if the time is equal to 1, then we know at the next second the color should change, so the color at the following second should be red. Otherwise, it should remain the same. Similarly, if the traffic light is yellow. If the time is equal to 1, then the next state should be red, next color should be red, otherwise it should remain yellow. That is a long yellow light. Last, if this color is green and the time is equal to 1, then the traffic light should change to yellow, otherwise it should stay green. Okay, our parentheses match. Well, that is not very pretty code. Why is it not very pretty? We have all of those repeated t equal 1s. Furthermore, this function needs to know about both timer states and colors. So we've really not done a very good job in keeping our principle of one function, one task. This function has to decide when to change color and also what color to change to. Well, we didn't like that very much. Let's try the other way around. I'll comment that out. Hash semicolon comments out an entire S expression. Okay, so let's try it the other way. Let's try first doing cases on the time. We'll say, let's define the color at next second, CT, to be if t is equal to 1, then next color of C, otherwise the color remains the same, it's still C. Again, the strategy is cases on T. We can still use the same tests that we had up above. Okay, so now all we have to do is write next color. So our strategy for next color will be structural decomposition on traffic light color. And we'll go through the same story. We will copy our template. Copy it down here. Uncomment it. I will fix the indentation by hitting Tab here. Okay, what's the next color after red? Oh, we've done this exercise before. The next color after red is green. The next color after yellow is red. The next color after green is yellow. Okay, so that's better. Each function has its own task. Next color knows about color, and color at next second knows about the timer. And I've written out some tests for next color. Okay, let's save this guy and run him. Oh, C is not defined. Oh yes, I copied part of it, but not all. There we go. And there it is, all passed, all tests passed. And down here are a couple of exercises that you can do to try to improve this code even more.